Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 7 Notes 4. Today we're talking about probability. So we're calculating basic probabilities as our learning target for today. Let's just review what probability actually is. Probability is a measure or an estimate of how likely it is that something will happen. So we're talking about it's kind of like a percentage. People talk about chances or odds. Probability is a ratio of how likely it is something will occur. They're given a value between 0 and 1, so they're always some sort of decimal. Okay, so 0% that it will have 0% chance that it will happen, or 100% chance that it will happen. The higher the degree of the probability, the more likely it is to happen. So basically, the closer you get to 1, the more likely it is that it will occur. And there's some notation that we use. P of A is how we read that. P of A is the probability of A, or the probability of whatever event A is representing. And then we also have a ratio that we use to calculate probability. That ratio looks like the number of successes divided by the total number of outcomes. So that's like a fraction that we set up in order to calculate our probability. So let's just talk about some basic probabilities. For example, rolling a die. Okay, if we roll a 1 on a die, what are our chances of getting, or if we roll a die, what are our chances of getting a 1? Well, number of successes, there's one success, because there's only one 1 on a die. Number of total outcomes is 6, so that's a 1 out of 6 probability, or approximately 0.16 repeating. Rolling a 2 or a 3, there's 1 2 and 1 3, so there's 2 successes here, still 6 total outcomes on a number cube. That's 2 out of 6, or approximately 0.3 repeating. Rolling an even number. On a number cube, there's the numbers 1, 2, 3, 4, 5, and 6. Half of those are even, 2, 4, and 6. So I have 3 successes, because I have a 2, a 4, and a 6. I have 6 total outcomes. That's 3 out of 6, which is the same thing as 1/2, or 0.5. I could have also reduced this up here. 1/3 would be that reduced fraction there. Rolling a number that is more than 2. If we want a number that's greater than 2, we're looking at 3, 4, 5, and 6. That's 4 successes out of 6 total possible outcomes. And 4 out of 6 is the same thing as 2 out of 3, which is also 0.6 repeating. Rolling a prime number, it would probably help to remember what prime numbers are. Prime numbers are numbers with 2 factors. And those factors are 1 and itself. You're going to use that prime number definition a couple of times in this unit, so you might want to write that down. So prime numbers are numbers that have only factors of 1 in itself. So that would be something like 2 has a factor of 1 and 2, 3 is a factor of 1 and 3, 5 is a factor of 1 and 5. I can't count 1 because 1 actually only has one factor itself. And I can't count 4 because 4 also has 2, and I can't count 6 because 6 also has a 2 and a 3. So I have 3 successes here, 2, 3, and 5. 3 successes out of 6 total. That's 3 out of 6, which is 1/2, which is 0.5. So there's some basic probability with rolling a number cube. One thing that it might be helpful for you to have, and so we put this picture on your notes sheet for you so you can reference back to it, is just what makes up a standard die. So, or a standard deck of cards, I mean. What makes up a standard deck of cards? Standard deck of cards has 4 suits, clubs, diamonds, hearts, spades. It has all of these numbers, ace, and then 2, 3, 4, 5, 6, 7, 8, 9, 10. It also has Jack, Queen, and King. These ones are considered the numbered cards. These ones are considered face cards. And ace is its own thing because ace isn't a number or a face. So that's just kind of our standard makeup of a deck of cards. So totaling 52. So 12 face cards, there's 4 suits, and there's a table on the back of your notes sheet if you haven't flipped it over yet that you can fill in. Cards in a deck, there's 52. Cards per suit, there's 13. Cards per number, there's 4 cards of each type, so that would be 4. The face cards, are Jack, Queen, and King. So there's 12 total. When we think about red and black, half of the cards are red and half the cards are black. So there's 26 black and 26 red. Okay, so diamonds and hearts are obviously red, clubs and spades are black. So if you're not a person who plays cards, you're probably not very familiar with what the deck of cards looks like. So now you have a picture and a little bit of the makeup of what that deck of cards is, because we're going to use that throughout our unit as well. And then let's take a look at actually finding some probabilities with those cards. Okay, so here's that table filled in if you needed that. So if I look at the probability of getting a spade, if I want to get a spade, that means I have 13 total successes because there's 13 spades in a deck. Number of total outcomes is 52. That would be 13 out of 52, which is the same thing as 1 out of 4, which is 0.25. If I want to get an ace, there are 4 cards of each type. So there's 4 aces per deck. There's an ace of spades, ace of hearts, ace of clubs, ace of diamonds. Still 52 total cards. That's 4 out of 52. That's the same thing as 1 out of 13, which is approximately 0.077. So not even a 10% chance there of getting an ace. You can see quickly how playing things like poker and card games are become really difficult because you have really small odds here. Probability of a red card, there are 26 red cards in the deck and there's 52 total. And it should make sense that 26 out of 52 reduces down to a half because half the cards are red. So that's 0.5. If you want to compare that to this one up here, I didn't put my 0 in front, so 0.077, 0.25, 0.5. You can see how small it is, how small the chances of you getting an ace. Ooh, Jack of clubs. This one's going to be even smaller. There is only one Jack of clubs in the whole deck. So if that one card is the card that you need out of a total of 52, you are looking at, I should make this approximately equal to, 0.019. So not even a 2% chance of you getting that Jack of clubs. By the way, if you haven't noticed already, I'm using these approximately equal to signs. We talked about this back, gosh, a long time ago. But this approximately equal to is anytime you're involving rounding. Whenever you're involving rounding, that's why this one can be equals and this one can be equals, because I didn't have to round these two numbers, but whenever I start involving rounding, then technically I'm approximately equal to that decimal. So face card, if I look at the face cards, we talked about how there's 12 face cards because there's 3 in each suit and there's 4 suits. So 3 times 4 gives me 12. 52 cards total still. 12 out of 52 reduces down to 3 out of 13. And 3 out of 13 is about 0.231. So about a 23% chance of getting a face card there. So let's just do a few random examples at the end of this. In number 1, it says you have a bag of 3 red marbles, 2 green, 5 blue. What is the probability of randomly grabbing a blue marble? So blue is like your success here. We need to figure out the total. So if we're looking at the total, we're adding up the total number of marbles, and 3 plus 2 plus 5 gives me 10. So if I'm doing success out of total, because that's what probability is, my success is the blue, which would be 5. My total is the 10. That's the same thing as 1/2 or 0.5. Most of the time you're going to leave probabilities as a decimal. If you got down to 1/2 and circled your answer there, I would totally take that. Any sort of reduced fraction means the same thing as the decimal. We just typically will find the decimal, and when you see probability, it will be written in decimal form. If I look at number 2, it says you decide you want to read Harry Potter. You go to your bookshelf and randomly pick out one of the books. What's the probability that you do not choose the first book in the series? Do not. This is one of those evil test maker tricks because they like to sneak those not words in, those words that negate whatever you're looking at, because it just messes with you. So if you don't know the Harry Potter series, there are a total of 7 books. So 7 books in the Harry Potter series, and you want the probability that you will not choose the first book. Well, there's only one first book. There's only one book that can be the first. So that means the successes here are actually the not first book, which are 6. So your success out of total would be 6 out of 7 because you're looking for not the first book. There's only one that's the first book, so then there's 6 that are not the first book. 6 out of 7 is the same thing as approximately 0.857. We also typically round probability out to that third decimal place. So you would look at the fourth one. What does the fourth one tell you to do with the third one? That's what we'll do with probability there. Let's take a look at number 3. It says you need to make a doctor's appointment next week. What's the probability that it is on a weekday? So weekday are your successes. This is what you want. That's another way to think of the success. What is it that you want? Okay, that's what goes on the top. If we think of the total, we know that there are 7 days in a week. Successes, weekdays, we know that there are 5, Monday, Tuesday, Wednesday, Thursday, Friday. So my success out of total, or what I want out of the total options, is equal to 5 out of 7, which is approximately 0.714. So about a 71% chance that you make your appointment on a weekday. And then last question on this notes page, this is a quick notes sheet today, which is kind of nice. Number 5, there are 4 male and 6 female puppies at a breeder. What is the probability that you will get a female puppy? That's hard to see on blue. There we go. So we have to think of the successes, or in other words, what we want. What do you want? We want a female, which there are 6. Then we also have to think about the total. Total is the 2 put together. There are 10. So if I do success out of total, which is what probability is, I'm looking at 6 out of 10. If I reduce that fraction, that's the same thing as 3 out of 5, so that would be a perfectly fine answer, or that's also the same thing as 0.6. No rounding necessary for this one. Okay, so that's going to take us to the end of our first notes video for the second half of the unit, Unit 7, Notes 4. Thanks for listening, and I will see you all later.